Hello, welcome to another video on critical reasoning. Today we're going to talk about Venn diagrams, and these can help us look at data and to categorize data. And this is very useful, especially if you're working in a business that you have a lot of data that has to be divided into categories for whatever reason, inventory, sales, and so forth. So Venn diagrams, also known as Venn diagrams, are diagrams that help test arguments for validity and to classify data. So for example, we have here any point in the circle represents apples. So for example, any type of apple would be within this circle. And then any point outside the circle, such as R, represents anything that is not an apple. So we have apple, we have not an apple. All right, let's go to the next one. In this example, there is a class of fruit and a class of apples. So the statement could be made is all apples are fruit. So we have here the entire category of fruit, but within that category, we have a group called apples. And in this diagram, the statements that could be made are no A are B or no B are A. So here we have two completely separate groups. They do not share any similar elements or characteristics, and therefore they do not overlap. In this set, we can see that point Y has elements of both class A and class B. So here we have two different groups or classes, A and B, and then some of those from each of them share characteristics together. So there's an overlapping area. And then point Z is only in class B. So it does not share any characteristics from class A. And then point X is completely outside of either class. So it is completely separate from A and B. And with the more data you get, the more complex the Venn diagrams can look. So for example, here this represents a real-world relationship among apples, fruits, oranges, apples in Paris, apples in restaurants in Paris, and fruit owned by Jim. So let's look at this entirely. We have our fruit, all things that are fruit. So that's our largest class. And then we go down to A, and A are things that are apples. So it's all apples within fruit. And then we have, in that, we have little a, which is the apple in my refrigerator. And then we go into another subclass, which is P. These are things that are apples in Paris. So if you're in the city of Paris, that's their share of apples. And then within Paris, we have R, which is a subset, things that are apples in restaurants in Paris. So if you have all the apples in Paris, and then you take out all, or you have all the restaurants within Paris that have apples, that would be that smaller circle. And then you have J, things that are fruit owned by Jim. So for example, Jim has some apples, but he also has some other fruits. And then we have O up here, which is orange. So Jim has some oranges, but then he also has other fruits such as maybe bananas and strawberries and so forth. So you can create all sorts of Venn diagrams and classify the data. So like, for example, you could take your own house and you have, the large group, your house, and then you can divide it by, say, rooms, living room, dining room, kitchen, so forth. And then you can say that, okay, in the sofa, well, the sofa is located in the living room. So that would be a subclass of the living room class. And you can make all sorts of diagrams in just your daily life. All right, let's do some practices. It says find some classes in the real world that would indicate the following relationships in this diagram. So what you could do right now, if you want, is pause the video and try to find a relationship that matches this diagram. Otherwise, you could just watch the video and I'll give you an example. So here we have two classes. We have C and we have B, and then we have A, which has characteristics of both. So I'm just going to use this one. I'm going to say that A equals U.S. citizens. Oops. U.S. citizens in New York City. And then for B, I'm going to say, okay, these are all city dwellers. People who are living in cities, not in the rural areas. And then C, we can make C all Americans or U.S. citizens. So here we have a relationship. We have C, which is all Americans. We have B, which is all people living in cities. And then we have A, which have U.S. citizens living in New York City. So what could we say about this area here? Let's create a new area. We'll call it D. So what could that be? That could be first of all, it's entirely in C, so that's Americans. It is in B, so it's city dwellers, but it does not include New York City. So this could be all other U.S. citizens living in cities. Oops, it's supposed to be other cities. Okay, please excuse my writing. So from this, we can classify data into different groups. All right, let's go to the next example. It says, how would you draw a diagram in which the statement that some apples are from Canada and some aren't true? So here we could say, let's see, we'll use A for apples. And then we'll use, let's see, B for Canada. All right, so we have Canada. And then we have apples. Well, not all of the apples are from Canada. So we're going to have A is going to partially align with B. And this represents the apples. This area, shaded area here, represents the apples that are from Canada. Okay. Next one. If all apples are bananas, what is true? What would, or if all, I'm sorry, let me say that again. If all apples are bananas is true, what would the diagram look like? Well, we know this is a silly statement, but let's go ahead and just work with it. So it says all apples, so all types, are bananas. Okay, so that simply means A equals B. And if A equals B, then they are strictly all in one category. All right, the next one. What would the diagram look like in this argument? So we have no ARC, no ARB, no CRB, so no ARC. Try to say this 3 times really fast. All right, so let's start off with A. So it says no A or B. And then the second line says no C or B. So A has no relationship with B or C. Now let's do B. B has no relationship with A and no relationship with C. Okay, and then we have C that is also completely separate. All right, so we have basically 3 separate classes, 3 separate circles, and that's what the diagram would look like. All right, now we can use Venn diagrams to solve problems. So in addition to classifying information, Venn diagrams can also be used to help solve problems. When doing so, the key is to work from the inside out, meaning we start by putting information in the regions of the diagram that represents the intersections of the sets. So I'll explain that more in the next slide. And we have our first problem. In a group of 100 customers at Big Red's Pizza Emporium, 80 of them ordered mushrooms on their pizza, and 72 of them ordered pepperoni. 60 customers ordered both mushrooms and pepperoni on their pizza. So we have 3 questions to answer. The first question is, how many customers ordered mushrooms but no pepperoni? All right, so let's go ahead and set this up. We have some of the key information here. Let's see. Let me just write. We have total customers. We have total customers equals 100. And we have the ones that liked mushrooms, or the ones that ordered mushrooms, equals 80. And the ones that ordered pepperoni are 72. And then we have 60 customers that ordered both. So I'm going to put M with pepperoni. That's going to be 60. So how do we figure this out? Well, let's see. We have question A. It says mushrooms but no pepperoni. So we're going to have mushrooms minus mushrooms with pepperoni. That's going to equal 80 minus 60. Okay, so that gives us 20. Now B says, how many customers ordered pepperoni but no mushrooms? So that's simply going to be pepperoni minus mushrooms with pepperoni equals 72 minus 60. That's going to equal 12. And then question C, how many customers ordered neither of these 2 toppings? So we have 100 customers. We need to subtract 20 who ordered mushrooms. We need to subtract 12 who ordered pepperoni. And then we need to subtract 60 who ordered both. And if we do the math, we're going to get 8. So how is that going to look? Well, let's do the diagram here. We have mushrooms. And then we have pepperoni. I don't know about you, but I'm starting to get hungry. And pepperoni is going to overlap with mushrooms. Okay, and then we just put in our numbers. So we know that 60 ordered both, so 60 is going to be in the middle. We know that 20 ordered mushrooms, just mushrooms, and we know that 12 ordered just pepperoni. And then we have 8 who are completely outside. They did not get mushrooms or pepperoni on their pizza. And that's what the Venn diagram for this problem would look like. All right, let's go to the next question. It's kind of similar. It says at Dan's automotive shop, 50 cars were inspected. 23 of the cars needed new brakes, 34 needed new exhaust systems, and 6 cars needed neither repair. So question A says, how many cars needed both repairs? Well, let's start with all the information that we have. Let's see, how many cars were inspected total? So our total was 50. Let's see, it says the ones that needed brakes, B for brakes, that was 23. The ones that needed exhaust, new exhaust systems, that would be 34. And then we have neither. Would be 6. All right, so let's figure out what the numbers are going to be. Well, we know that the total is going to be 50. So 50 minus 6 gives us 44. So that means that 44 cars needed brakes and or exhaust systems. So now let's take 44 and we're going to set that equal to 23. That's going to be your brakes plus 34, which is our exhaust system. And then we're going to subtract B with E, which has ones that needed both. So we just need to figure this out using algebra. 57 minus BE, and that gives us, let's see, it gives us 13. Is that right? 13, 7, 6, yeah, 13. All right, so 13 cars needed both repairs. All right, so we can go ahead and start working on our diagram here. Let's see, we need brakes. And then we need exhaust. And they're going to overlap. All right, and we know that 13 needed both. So we're going to put 13 right in the middle. We know that 6 needed neither, so they're going to be outside. So we know that 23 needed brakes. So we're going to say 23 minus 13. That's going to equal 10. So that means 10 cars only needed brakes. And then for exhaust, we have 34. We're going to subtract 13. And that leaves us with 21. So 21 needed just the exhaust system. And if we just, to prove this out, we take 10 plus 13 plus 21 plus 6. That should equal 50. So let's see, 10, 20, 30, 34. Up, 10, 20, 40. Yep, and it equals 50 precisely. All right, so this is what our Venn diagram would look like for this problem. All right, let's go to the next one. And the next one's going to be a lot more intense. Like I said, if you want to stop on any of these, you can and figure them out yourselves. Otherwise, we're going to continue. All right, it says a survey of 85 students asked them about the subjects they liked to study. 35 students liked math, 37 liked history, and 26 liked physics. 20 liked math and history, 14 liked math and physics, and 3 liked history and physics. 2 students liked all 3 subjects. All right, so we've got a bit of a mess here. So let's go ahead and, before we read the questions, let's organize our data and figure out what do we have. Well, we have the total students, and that's 85. The ones that liked math was 35. Ones that liked history was 37. The ones that liked physics was 26. Now, the ones that liked math and history is 20. Ones that liked math and physics is 14. And the ones that liked history and physics equals 3. And then the ones that liked all 3, there is only 2 that liked all 3. Okay, let's go ahead and create our Venn diagram just to get that started. And that's going to be our math here. And that's going to be physics. And then we have our third one. This is going to be history. And we can go ahead and start putting in some of the numbers. So we know that 2 students liked all 3 subjects. So 2 is going to be in the dead center. And then when we know that, let's see, there's 20 students that liked math and history. So that's going to be, let's see. Oh, and let's see. Let's go ahead and start working on these. All right, so for only math, we need to find out, for letter A, how many of these students liked math or physics. So let's start out with math. So we know that 35 students liked math. And we're going to subtract 20 because those are students that liked math and history. And then we're going to subtract 14 because those are students that liked math and physics. And then we're going to add 2 because we don't want to double count. So we're going to add 2. And that leaves us with, and excuse my math, I'm running out of room here. That leaves us with 3. All right, so there are 3 students only who like math, who like math only. Now we got to figure out for physics. Well, physics, 26 students liked physics, but we got to subtract out 14 who liked math and physics, subtract 3 who liked history and physics, and then add 2, and that's going to be 11. So we have 11 students who liked physics only. Now the next question says, how many of these students didn't like any of these 3 subjects? Let's see. We'll skip that one. Let's go to how many of these students like math and history but not physics. We're going to do C first. So for C, how many of these students like math and history? Well, we need to find out about how many students liked history. So we know that for history, 37 students liked history, so we need to subtract out 20 who liked math and history, subtract 3 that liked history and physics, and then add 2. And that is going to give us 16. So 16 students liked history only. Now, we need to find out who liked these 3 spots, math and physics, physics and history, math and history. So, for math and history only, we're going to take 20, but we need to subtract 2. That will equal 18. So for math and history, that's going to be this slot. We're going to put 18. For math and physics, we know 14 liked math and physics. We need to subtract 2, and that's going to give us 12. So for math and physics right here, we're going to put 12. And then for history and physics, we know that 3 liked them. We're going to subtract 2, and we're going to have 1. So only 1 student liked history and physics. Now, we've got all the spots circled, and it says how many of these students like math and history but not physics? Well, we can look right here. The answer, math and history but not physics, that would be 18. So letter C is going to be 18. All right, but letter B, how many of these students didn't like any of the 3 subjects? Now we need to actually subtract or add these all up together. So I'm going to just take out my calculator, make it easy. So we had a total of 85 students. And let's add these numbers together. So we have 11 plus 12 plus 3 plus 3 plus 18 plus 16. Whoops. I think I made A's. No, I didn't make any errors. Okay. All right, we have 85 students, and if we add all of these totals up, we have, I think it looks like it's going to be 63. So 85 minus 63, it's going to be 22. So we have 22 students who would be outside this Venn diagram because they didn't like any of the classes. And that should be it. So that's going to be our total. So if you have any comments or suggestions, please feel free to leave them. If you've liked the video, please send a like. Thank you very much.